Good morning, students. Happy Wednesday. So today you guys are going to be working on multiplying polynomials day 2. So it's the same exact concept, just maybe a little bit more context or a little bit difficult of multiplication. So the warm question for you guys here today is, I am the area of a rectangle. My length is 4x minus 1 and my width is 5x plus 3. Remember, area is length times width. So go ahead and try this one on your own, pause the video, and check your answer with what I get. So if I type this in here, guys, it would be A equals, the length is 4x minus 1, and the width is 5x plus 3. Okay, so again, you guys can either use the box method or distributing, whichever one makes more sense to you. I'm going to go ahead and use distributing, but feel free to use the box method. I will also use that in today's lesson as well, if you'd like to see that again. So we want 4x times 5x, so 4 times 5 is 20. And then remember x to the first, add those together, we get x squared. 4x times 3, 4 times 3 is positive 12, and bring the x along with us. Then we need to distribute the -1. Make sure you take the negative with it. Okay, -1 times 5 is negative 5x. -1 times 3 is positive 3. Combine those like terms, which are your x's, and that gives us 12x minus 5 is 7x. Bring the 3 down and the 20x squared. And guys, remember to make sure that these are in standard form, meaning that the exponents are in order. Okay, the last one obviously should not have an exponent. And that is the area. So for these guys, your answer becomes an expression, not a number. So you guys should get used to not always just getting one number for an answer. Can come out to be an expression. So same notes as yesterday, double distribution or FOIL. Okay, remember FOIL just means first, outer, inner, last. Okay, so first would be multiplying the first two, outer is multiplying the outside two, inner is multiplying the inner two, and then last is multiplying the last two. So you can also remember as FOIL. I just remember it as double distribution. So the first question here says a triangular garden has a base of x squared minus 3 and a height of 2x minus 1. What is the area in which the gardener can use for her plants? Okay, so this is a context question, so you got to remember what the area of a triangle is. So the area of a triangle is either 1/2 times base times height, or I typically like to do base times height divided by 2. Okay, but either one works. So if you put that into the context, we know that the base is x squared minus 3. And the height is 2x minus 1. And that's going to be put all over 2. So we need to do our double distribution. So x squared times 2x. Remember, we have the 2, and then x to the 3rd power because we want to add those exponents. Negative x, or x squared times 1 becomes negative x squared, or negative 1x squared. Then distribute that -3. So -3 times 2x is negative 3 times 2 is -6x. And lastly, we have -1 times -3 is +3. And remember that this whole thing is still all over 2. So this is kind of funky because we need to make sure we divide each term by that. Okay, so remember way back when we talked about how each term needs to be divided? So same thing here. Make sure you divide each coefficient by that 2. Okay, so each term has to be divided by that 2. So when you get your answer here, it's going to be 2 divided by 2. Well, that's 1. So it would be x cubed. -1 divided by 2 would be -1/2 x squared. -6 divided by 2 is -3x. And 3 divided by 2 is just 3/2. So when you plug those in there, remember you just want the coefficients because the variables are already given. So 1, -1/2, -3, and +3/2. That's your answer, guys. It says, what do you guys notice that is slightly different from FOIL problems? Slightly different from the FOIL problems we practiced yesterday. Could be something you see in actual binomials or in your answer. Okay, so give me something that you see that's slightly different in this problem that you didn't see yesterday. So what might be new today? And the next problem we have here, go ahead and copy and paste into your show your work box. And again, guys, remember you can use the box method if you'd like. I'm going to practice that on the next one, but not this one. So if we do distributing, give me 1 second here. Looks like we've got a squared that didn't copy right. Okay, so 9x times x squared is 9x cubed. 9 times -10 is -90x squared. And 9x times 1 is +9x. Distribute that -2, you get -2x squared, +20x, and a -2. So guys, the one difficult thing about these problems is really making sure you're being very careful about all your multiplications, because just the tiniest mistake, even if it's just a sign, can mess up the whole problem. So make sure you combine your like terms. And just as you guys remember yesterday, make sure you don't forget the sign. So that's a -90. So -90 and -2x is -92x squared. +9 and +20 is +29x. Bring down that -2 and that 9x cubed. So 9, -92, +29, and -2. Okay, the next one. You guys can use either box method or distribution. I'm going to go ahead and show you guys box method just so that you can see this one in a little bit different. So we have 3 terms by 3 terms, so we need a 3 by 3 box. Don't worry about making your box perfect. As you know, I will be crazy about it. So don't spend all day doing it. See, look, I even made mine wonky. All right, so b squared minus 3b negative 6. Make sure each term has their sign with it. So b squared plus b or times b squared. Remember, you add those exponents, so it's b to the 4th. Negative 3b times b squared is negative 3b to the 3rd. Negative 6 times b squared, negative 6b squared. B squared times negative 8 is negative 8b to the 3rd. Negative 3b times negative 8b is positive 24b squared. Negative 6 times negative 8 is 48, and bring that b along with b squared times 6, 6b squared. Negative 3b times 6 is negative 18b, and negative 6 times 6 is negative 36. Then we can go ahead and combine our like terms. So guys, remember yesterday how I said if you do this, typically your diagonals end up being your like terms. And that's because the original equations or the original expressions are in standard form. So that's kind of something that's a little nice about this box method. So you get b to the 4th, negative 3 plus negative 11 is, negative 8 is negative 11, b to the 3rd. Negative 6, positive 6, ooh, those cancel each other out. So I have 24b squared. 48 minus 18 is positive 30b, and last but not least, negative 36. And there's your answer. Kind of looks like a fun game. Okay, I'll do this one by distribution, just to show you guys the difference. So you can go ahead here, n squared times 3n squared, that'd be 3n to the 4th. Negative 4n times n squared is negative 4n to the 3rd. And positive 8n squared. And this is where it gets a little tricky because we have to distribute the 2n now. So 2n times 3n squared would be positive 6n to the 3rd power. Almost made a little mistake there. Got to be careful. 2n times negative 4n would be negative 8n squared. And 2n times 8 is positive 16n. And last but not least, we need to distribute this negative 3. Oof, this is where it gets tricky because I have so much stuff. I'll put it underneath. So we have negative 3 times negative 3n is negative 9n squared. Negative 3 times negative 4n is positive 12n. And last but not least, negative 3 times 8 is a negative 24. And then you can combine your like terms. So we have some n cubes here, some n squareds, and if you already see, the two that I just circled cancel each other out. I love when that happens. And lastly, we have some n's. So starting at the front, or the largest exponent, because we want it in standard form, 3n to the 4th power. Negative 4 plus 6 is a positive 2n to the 3rd. The positive 8n squared and the negative 8n squared cancel each other out. So we're just left with that negative 9n squared. And positive 16 plus 12 is 28n and negative 24. So personally, guys, I like for these bigger ones, I think it's a little bit easier to keep your thoughts organized with the box method, but either way works. Okay, for these ones, we have 3 different functions, f of x, g of x, and h of x. Okay, the first one asks us to find the sum. So you gotta think, what is the sum? Well, the sum is to add them together. So I'm gonna go ahead, and it says we want g and h. So I'm gonna go ahead and copy g and h so that I can plug it into my show my work box. Okay, and we want to add these 2 together. So technically you guys could just go ahead here and add straight down the column, but sometimes that can get a little confusing. So I'm gonna go ahead and put them next to each other like we're used to seeing. Okay, so this is just like combining like terms, guys. Okay, negative 2x plus 9 or plus 7x is 5x, and negative 5 and negative 1 is negative 6. Okay, so it's just a little bit different of notation because you're adding in that function notation in the words sum. So it's the same thing you guys have always done, it's just adding a little bit notation. Okay, then number 8 says find the product of g and h. So again, we want these last 2. So exactly what we had before, except this time we want to multiply them. And I'm just going to go ahead here and delete everything and change to multiplication. Okay, so we can go ahead and distribute. So negative 2 times negative 7 is negative 14, and then you have x squared because there's 2 of the x's. Negative 2x times 1 is a positive 2x. Negative 5 times 7 is negative 35. Bring that x along. And negative 1 times 1 or 5 is a positive 5. Last but not least, make sure you combine those like terms. 2 plus negative or minus 35 is negative 33. X, bring down that 5, bring down that negative 14x squared. Okay, so guys, these are really, really tedious, so make sure that you're being careful about them. Okay, next one. It says, look carefully at the operation between the polynomials. So for this one, you can tell that there is subtraction between them. So when we subtract, how I always do this is I distribute the negative first. So that negative double negative becomes positive, and then this double negative becomes positive, and then we can treat this like addition. So we can combine our like terms. So we have 5x and 1x is 6x, and 2 and positive 7 now is positive 9. So remember, a negative symbol changes the sign. Okay. You can also break that down into 2 steps if you'd like. Last one here for you guys today is a multiplication one, and this is multiplying 2 monomials. So think if you can think back to your skills from Monday. And I don't think this is going to copyright, so I'm just going to go ahead and write it. So we have 5x y to the third, negative 2x to the fourth. So remember, guys, we want to distribute. So negative 5 times negative 2 is negative 10. And then add the exponents. So multiply coefficients, add the exponents. So x to the first times x to the fourth is x to the fifth. And there's nothing to combine with those y's. So it's y to the fifth. So that gives us negative 10, x to the fifth. And change that 5 to a 3. It does not change. There's nothing to combine it. Okay, so make sure you guys do the worked out examples and the try your own, and make sure you attempt that OHS quiz. We have 3 attempts. Okay, so make sure you give them all your attempts. Fill out that exit slip for me and have a fantastic day, guys.